Welcome back. This is Mr. Tipton, and we're going to move on from integers to talk about rational numbers and operations. Rationals on the number line is what we're looking at today. We want to be able to plot rational numbers, both positive and negative fractions and decimals on a number line. We also want to make sure that we can represent adding and subtracting, or combining, rationals on the number line. First, let's talk about what rational numbers are. Right here, rational numbers are numbers that can be written as fractions. Okay, so if you can write it as a fraction, that means it's a rational number. 3/4 is already a fraction, so obviously that's a rational number. 0.3. If you say this without the P word, you're saying 3/10 if you read that correctly. 3/10 is also, or can also be written like that, as a fraction. Okay? So, decimals. Not all decimals, but this one anyway is a rational number. How about -4? Anytime you take a number and divide it by 1, you get the same thing. Anything divided by 1 is that number. So yeah, even this, even -4 is rational. It can be written as a fraction just by putting it over 1. Alright, then we have a repeating decimal, 0.6 repeating. Of course, what this means, switch colors here real quick. The bar over that 6 means the 6's go on forever, forever, forever. 6, 6, 6, 6, 6, 6. Okay, ran out of paper. Alright. And yes, repeating decimals can be written as fractions. 0.6 repeating is 2/3. Okay. At some point we will talk about how to convert a repeating decimal into a fraction, but for now, just know that yes, repeating decimals can be written as fractions, so they are rational. Alright. Now, if something is not rational, it's called an irrational number. IR means not. Irrational. Things that are irrational or not rational means they cannot be written as fractions. Alright? The most popular irrational number is this guy right here. A lot of you will recognize this as the symbol for pi. Pi. Alright? And maybe you're thinking, well, don't we use 3.14? That's a decimal. I could write that as a fraction, couldn't I? Well, okay, yes, but 3.14 is just, it's an abbreviation. It's rounded. It's pi rounded, okay? Pi is a decimal that goes on forever, and it doesn't repeat. There is no pattern, okay? Another example of an irrational number would be the square root of 5. Okay, the square root of any non-perfect squares is also irrational. Not talking so much about irrationals right now. We're focusing more on the rational numbers, things that can be written as fractions. Alright? So next up we're going to plot some rational numbers on the number line. No big deal. Here we've got 4. Okay, we know positive numbers are on the right side of 0. Negative numbers are on the left. -7 is over here. Okay, do those with red. And now let's do some blue ones. Here we've got 5.5. Now, I've got 1, 2, 3, 4, 5, 6, 7, 8, but it doesn't say half anywhere. Hopefully we know that 5.5 is halfway between 5 and 6. So it should, when we plot the point, it should be right in between, right in the middle of 5 and 6. Okay? Same deal with -6.5. 6.5 or 6 and 5/10 is the same thing as -6 and 5/10. -6.5 is halfway between -6 and -7. Okay, a common mistake would be to put it over here between the 6 and the 5 because we're used to something that is more than 6 being on the right side, but we're talking about negatives. Negative numbers, so the bigger or the stronger that negative gets, it's actually going further away from 0, so further to the left on the negative side. Now, 0.25, that is between 0 and 1, but it's less than halfway between 0 and 1. So putting the green dot right here, that would not be good because that's halfway. Alright, we're going to, instead, it's only about a fourth of the way, so we're going to make sure that our dot is closer to 0 than it is to 1. And then this guy, negative 3 and 3/4. 3/4 is greater than a half, so we need to make sure that our dot is closer to negative 4 than it is to negative 3. Alright, so we can still plot numbers, plot our rationals on the number line. We just have to be careful when we have our fractions and our decimals. Which whole number, which integer are they closer to? Make sure your dot is closer to the correct number. Or if it's a half or a 0.5, make sure it's right in the middle, right in between. Alright, let's do some combining of integers on the number line. We're going to use the same rules that we used for combining in the last unit. Right here we've got 7.5 plus negative 3. And I'm going to switch over to black. Oh, plus a negative, adding a negative. I do not like that. Do not like two signs in a row. So I'm going to rewrite adding a negative is the same thing as subtracting. And 7.5. Oops. Undo. 7.5 minus 3. Okay, 7.5 right here between the 7 and the 8. And if I need to, I can go 1, 2, 3. I'm going to end up at 4.5 or 4 5/10. Okay, when you're subtracting, you're moving left along the number line. When you're adding, you're moving right. Make sure you have your expression in OSC form, or that won't always work. We need to know how to do the horizontal number line as well as the vertical. And here we have a nice vertical number line on the left side here. And our expression is negative 4 minus negative 7 1/4. Again, I don't like these two signs in a row, so I'm going to rewrite it. First number stays the same. Subtracting a negative is the same thing as adding. Alright. Then I need to combine these. I've got 4 on the negative team and 7 1/4 on the positive team. Now, can you have a fourth of a person? No, you can't. But we know the positives are going to win, and they're going to win by 3 1/4. If you needed to, you could come over here and subtract. Oops. Get my eraser. Maybe. Here we go. It would be 7 1/4 minus 4 is 3 1/4. Positives are going to win. And on the number line, start at negative 4. And we're adding 7 1/4. 1, 2, 3, 4, 5, 6, 7. And a fourth. We're not going halfway. Got to be closer to the 3 than we are to the 4 for our answer. Alright, rationals on the number line. Make sure you know what a rational number is and what it is not. Make sure you know how to plot points and that you can combine rationals using the number line. Make sure those notes are done. Write down any questions you have, and we'll see you soon.